Hey guys, so today we're going to talk about section 10.6, which is arcs and central angles. So let's start with just basic parts of a circle. So you're always going to have a center of a circle, and whatever the letter is that's next to the center, that is how you actually name the circle. So this is called circle M. So given circle M, we're going to draw the following parts of a circle. We're going to draw a radius called MT. So a radius is a segment that starts at the center of the circle and extends to the edge of the circle. And since it's called MT, those are the two letters that we're going to use to name the radius. All right, next one is diameter AC. So if you guys remember, a diameter is another segment that starts at one end of the circle, travels through the center, but it keeps going to reach the other end of the circle. So a diameter is actually made up of two radii. Since it's called AC, those are the letters that we will use to name our points for the diameter. Now the next part is a chord called JR. A chord is just like a diameter. It starts at one end of the circle, travels anywhere to the other end of the circle, and we'll call it JR. Now, if the chord passes through the center, which it does not have to, that would actually be called the diameter. So for this part here where it says name another chord already drawn on the circle, that would be the diameter AC. So a diameter is actually a special type of chord because it travels through the center. All right, so those are the basic parts of the circle. So let's actually just talk a little bit about what you guys remember formula-wise for circles. So example 1 here says, if D equals 16 centimeters, meaning the diameter. If the diameter equals 16 centimeters, we are going to find the circumference and the area of the circle, and we're going to leave it in terms of pi. So if you don't remember the circumference formula or the area formula, it is on your yellow formula sheet. There are technically two formulas for circumference. Circumference equals 2 times pi times r, or you can do diameter times pi. It's up to you. The reason why these are both the same formula is because, remember how I explained earlier, a diameter is really just two radii put together. So if I gave you the radius, you may want to stick with this first formula, but since I actually gave you a diameter of 16, it'll just be a little bit quicker if we stick with the second formula. So we are going to say circumference equals 16 times pi. And it wants us to leave in terms of pi. That means do not make this a decimal. This is simplified in terms of pi. The circumference is just 16 pi. Technically, I should put centimeters after it, since those are the units. Now, if you remember, circumference is kind of like perimeter of the circle. Basically, if you were to take a string and measure around the circle, that would be the length. It'd be 16 pi centimeters. All right, so let's now move on to the area of the circle. And if you look on your formula sheet, if you don't remember, the formula is pi radius squared. And that is the only formula for area. So since we don't have radius, we'll have to find the radius. So if you know your diameter is 16 centimeters, it's really just two radii put together. So you're going to split it in half, and you're going to get your radius. So the radius is just 8 centimeters. So we're going to plug in 8 in for r. I'm going to put it in parentheses, and I'm just going to square the 8. So it's not that the pi is getting squared. if you were to type this all into your calculator, let's say to get a decimal version, which we're not going to do, make sure you put the 8 in parentheses, just the 8, not the pi. This way your calculator does not square pi as well. But we are not going to do that because the instructions told us to leave it in terms of pi. So we're just going to square the 8 on our own, which gives us 64. And typically we usually see the number in front of pi. So we're going to say the area is 64 pi. And anytime you're talking about area, your units are always going to be squared. Doesn't matter what shape you have, whether it's rectangle, triangle, or a circle, your units are always squared. So that is the area of the circle. All right, so now we're going to talk about certain types of angles, certain types of arcs that can be found in the circle. So here we have circle C, because C is the center. We're going to talk about what is a central angle, a minor arc, a major arc, and a semicircle. For a central angle, it is an angle whose vertex is at the center of the circle. So feel free to pause this to write that down, but I'm going to go ahead and sketch out an example of a central angle. So we're going to have an angle whose vertex, meaning the middle point of the angle, is going to be at the center of the circle. So imagine I have one segment extending here, another segment extending here. I have now just created a central angle. Let's actually give it a name. Let's call it angle ACB. So I'll just write next to it, angle ACB would be the central angle. All right, next we have a minor arc. Anytime you have a central angle, it actually splits the circle up into 2 arcs. I'm going to color coordinate these. The minor arc is going to be the arc, meaning the curved part of the circle, that is the smaller piece. So the minor arc is a circle's arc whose measure is less than 180 degrees. We'll talk about that in a moment. So since you have a minor arc, the other side is known as the major arc. So I'm going to color this in green. You can visually see that the rest of the circle is a curve that is very large, wrapping from A all the way to B on the left-hand side. So the definition for major arc is a circle's arc whose measure is greater than 180 degrees. Now I want to talk a little bit about naming these arcs. Just like you can name a central angle ACB, I want to use these letters to also name the minor arc. So when you are naming a minor arc, which in this case is the red arc, you simply take the 2 endpoints of the arc. So this is going to be called arc AB, and the symbol for the arc is just a little arc above the letters. Now, when you name the major arc, you also want to use AB because those are the endpoints of the major arc. However, if I call it major arc AB, it's the same exact thing as the minor arc, so you really wouldn't know which one I was talking about. So typically, whenever you have a major arc, you'll see a random third point, let's just call it D, drawn on the major arc. This way, you can start at one of the endpoints. It doesn't matter if you start at A or if you start at B, and just go either, just follow the direction of the point. So you're going to call this major arc A, D, E. So you're going to use 3 letters when you're naming the major arc, but again, you're still going to use that arc symbol. Now you can also go backwards, so if you wanted to call it arc EDA, that's fine as well. Now we don't have an example of this here, but I'm sure you guys can figure out what a semicircle is. A semicircle is simply half a circle, but here's the definition of it. It's an arc with endpoints that are the endpoints of the diameter. So let's actually draw an example of a semicircle. So let's say I have a new circle here. I'll just call it circle P. And I'm going to draw a diameter. Let's name it EF. Anytime you have a diameter, it's going to split the circle in half, and they're going to be 2 equal pieces. So this would be a semicircle. So would the bow. And hopefully you guys know that a full circle makes 360 degrees. So if we were to measure out half a circle, it's only 180 degrees. So we're going to use this idea now to talk about measuring these arcs. So we're just going to focus on the minor arc versus that major arc. All right, so you guys have this on your notes here. We're just going to fill in the blank. So under arc measures, the measure of the minor arc equals the measure of the corresponding central angle. And we'll do an example in a second so you guys can see what that means. And then if we wanted to find the measure of the major arc, that will equal 360 degrees minus either the minor arc, if you have that info, or if you have the central angle info. So let's take a look at an example here. So for example 1, I have circle S. As you can see in red, there is a minor arc RT, and then the rest in blue is going to be that major arc RQT. Let's say you are given the measure of the central angle. So I'm just going to draw a little arc here. Let's say this is 50 degrees. We're going to determine the measure of minor arc, which is in red. And then we're also going to figure out the measure of major arc, which I'll just highlight here in green. All right, so let's start with the minor arc. So according to what we just wrote down earlier, the measure of the minor arc is going to equal the measure of that central angle that corresponds with it. So if your central angle is 50 degrees, so is that minor arc. So we can just say the measure of minor arc RT equals 50 degrees. That's it. And then if you want to find the measure of the major arc, which in this case we'll call major arc RQT, how do you think we'll figure that out? Well, a full circle is 360 degrees. So according to the rule here, we're just going to take 360 degrees and we're going to subtract from it the measure of the central angle, which will be the same thing as the measure of the minor arc. So 360 degrees minus 50 is 310. So 310 degrees is the measure of the major arc. If you want to label it, you can just write it on the outside. 310 for the major, 50 degrees for the minor. That is it. So now we're just going to do a bunch of different examples where, let's say I don't just have one central angle, but I have a few central angles. So let's look at example 2. Example 2 says name all of the central angles, and then I'm going to give you guys some degrees for these angles, and we're going to find measures of different arcs. So if you look at the central angles, we have quite a few. We can start here with this angle on the left, which is angle MHA. So just start listing them out. We also have another central angle, the one right next to it. I'll just put double arcs so it's different. That is angle AHT. And then technically there is a third one because I could put these two angles together and make a really large central angle. I'll just put triple arcs on it so it's different. And that would be angle MHT, the entire thing. So we technically have 3 central angles in this one picture. Well, let's focus on 2 of the central angles. So let's start with, if the measure of angle MHT is 104, so MHT is that entire central angle. So if this whole thing is 104 degrees, and we're given that angle AHT, which was the smaller one on the right-hand side, is 62, we're now going to find all these arc measures. Before we even begin, we should probably figure out the measure of the first angle, MHA, using the 104 and the 62 degrees. So how do you think we'll do that? Well, we're just going to subtract them, that's all. So do 104 minus 62, and that will give you 42 degrees. So now we know each of the central angles, and we can now figure out these different measures for the minor arcs. So let's start with minor arc MA. So if I just kind of highlight this, minor arc MA, it's going to equal the same as its corresponding central angle. So when I look at my 3 central angles here, the one that goes with it is going to be angle MHA. So this arc is 42 degrees as well. All right, well, let's take a look at the next minor arc, which is AT. So it's going to correspond with central angle AHT, which was 62 degrees. And then let's take a look at minor arc MT. So minor arc MT, if I sketch this out here, that's wrapping around all the way from N to T. So that's going to correspond with that large central angle, MHT, which was 104. So that will also be the measure of this minor arc. So the last measure we have to find is arc MST. So that is a major arc. We learned earlier that major arc measures are going to be over 180. So how do you think we're going to find the measure of arc MST? Well, it's always 360 minus the central angle that goes with its minor arc. So we're going to take 360, subtract it from 104 because this large minor arc is 104. So 360 minus 104 will give us 256. And if you want to double check your work, you can just take 256, add it with 42, add it with 62, and make sure everything equals to 360. Or you can just do 256 plus 104, make sure that equals to 360. All right, let's do another example. So the same idea. We're going to name the central angles, and then some minor arcs, major arcs, and then just write down some measures. So naming the central angles. We have angle TPS, which is over here on the left. Then you have the one next to it, RPS, on the right. And then we actually have a semicircle, TSR. So I'm going to save that because I'm going to label that as a semicircle. So I'm just going to say there's two central angles here. Harpy says name two examples of minor arcs and their major arcs. So let's talk about minor arc TS. If I were to pick minor arc TS, its major arc would be the rest of the circle. Remember, it needs three letters. So that would be arc T, arc S. So that's one example of a minor arc and its major arc. Let's look and see where else we could label that. Well, I can switch gears and come over here and talk about minor arc SR. So then its major arc would be the rest of the circle, which could be RTS. That would be the other example of a minor arc and its major arc. All right, so now part C says what kind of arc is arc TSR? So I'll highlight that in blue here. Well, you'll notice it's half a circle, which we call a semicircle. And the reason why we know it's a semicircle is because if you look at the endpoints, T and R, that's a diameter. And I know it's diameter because when I connect them, it's going through the center, which is P. So anytime you see that diameter, you automatically have two semicircles. All right, so let's actually find some measures. So we've already been given that angle RPS is 110 degrees. So we're just going to find the following measure of these arcs. So let's look at RS. So RS, this arc here, corresponds with the 110. So it's also going to be 110. Let's look at RST. So RST, I've already drawn that out in blue, is a semicircle, which is going to be 180 degrees. And then if you look at RTS, so you got to follow the letters here. So I'm going to do this in green. R, go through T, stopping at S. You'll notice it's a major arc. It's opposite of the minor arc RS. So in order to figure that out, you're just going to do 360 minus that minor arc 110. And you're going to get 250. So we're going to be working a lot with 360 degrees and 180 degrees to figure out arc measures. All right, we're going to do another example. So here I have a few central angles. They're actually already labeled with degrees for us, and we're just going to find the following arc measures. So if you start with TQ, TQ is a minor arc. It's going to be the same as 120, because that's the corresponding central angle. If you take a look at QRT. Make sure you follow those letters. Start at Q, go through R, go up to T. You'll notice that's the major arc that goes with minor arc TQ. So you're going to do 360 minus 120, which will end up giving you 240. Okay, so now let's take a look at arc TQR. So I'm just going to erase what I have here. I'm going to follow TQR. Okay, you'll notice that I can solve this one of two ways. I have a semicircle because T and R is actually a diameter going through the center. So I know that it's going to be 180 degrees, but I could also add these arcs, 120 and 60, to get 180. All right, let's take a look at arc QS. Now, there's technically two ways I could have gone from Q to S. I could have gone counterclockwise. If I did that, that would have been a major arc, because you can see it would have been bigger than half a circle, which is bigger than 180. So this is actually talking about the minor arc of QS. So we just need to figure out how big this arc is. Well, notice how when I look at my initial picture, I'm given all these angles, except for this fourth one. So how do you think we can figure out that fourth one? Because once we know the fourth one, we can then add it with 60 to get the measure of arc QS. Well, how many degrees is a full circle? It's 360. So you can add up the three angles that you have, 120 plus 60 plus 80. And then once you get your answer, you can subtract it from 360 to get that fourth angle that we're missing. So when you add these together, you get 260. So 360 minus 260 is 100. So we now know this missing angle here is 100. Can you guys think of another way that we could have figured out that was 100 degrees? It has to do with the diameter. If I take a look at T to R, that makes a straight line. So 80 plus this missing angle would have made 180 degrees. So there's actually two ways to figure it out. So we now know this is 100. And again, we're just trying to find the red arc QS. So we're going to add 160 to get 160. All right, so now we have everything, and we can answer the last question, which is finding the measure of arc TS, which will correspond with 80 degrees. Oh, we have one more, and then we have to find arc RST. So that's going to be a major arc. You'll notice it's a semicircle. So how many degrees is a semicircle? 180. Okay, I believe this is the last example that we have here. It's the same exact idea. So before we even start finding all these arc measures, let's figure out this missing piece of the circle. And we'll do exactly what we did before. We're going to add up all the angles that we currently have. So 70 plus 110 plus another 70 plus 35 gives you 285. Then we can subtract it from 360. And we'll get 75 degrees. So that missing piece is 75 degrees. And now we can just go through the list add up certain angles and figure out arc measures. So if we look at arc AED, I'm just going to follow the letters, AED. Again, this is half a circle. It's a diameter that is making up those endpoints. So half a circle is going to be 180 degrees. All right, I'm going to erase that, start over. Now let's take a look at arc BE. So remember, since there's only 2 letters here, it's talking about the minor arc. So I'm going to go the shorter route versus wrapping around the other way. So you're going to do 70 plus 75, which gives you 145. All right, so now we're going to take a look at arc ACE. So arc ACE is a very large major arc. So notice that it's 75 plus 35 plus 70 plus 110, or you can just do 360 minus this little wedge, which is 70. Either way, you'll still get your answer. So that would be 290 degrees. All right, almost done. Now let's take a look at AEC. So going back this way now, AEC. So again, you can add 70 with 110 with 70, or you can subtract 75 plus 35 from 360. I'm just going to add 70 plus 110 plus another 70. That gives you 250. Almost done. So now we're just going to take a look at AC. So it says minor arc AC, so I want to go the shortest route from A to C. That's just simply adding up 75 plus 35, which is 110. And last but not least, we have arc CDE. So CDE, you'll notice that it's half a circle because it's going from one endpoint to the other of a diameter. And you can just see here, 110 plus 70 is 180. Okay, those are the notes for today. Nice job. So tomorrow we'll do a little bit of a recap, and then we will just do some worksheets. Great job.